Let's go ahead and find the volume of this solid of revolution. We are rotating the region R around the y-axis, and we are going to use the shell method. So to create shells, we need to have a vertical integration element. So there's our vertical element, and when that rotates, so that's at a random x, and when that rotates around the y-axis, it's going to create a cylinder. The area of a cylinder, we know, is the circumference of the base, 2 pi r, multiplied by the height. Because this integration element is vertical, we are going to be integrating with respect to x. There will be cylinders for all the x values between 0 and 2. In other words, we need to figure out what the radius and the height are in terms of x, since we will be integrating with respect to x. Well, the radius is this distance right here, and that distance already is denoted as x. We know that x is the distance from the y-axis, which is corresponding to the radius of the cylinder. And then the height of this element, right there, that's given by the function. So that function is actually measuring the height of the corresponding cylinder. So we'll multiply this by 8 divided by 1 plus 8x squared. So that is the area function. And to get to the volume, we integrate area. So we are going to integrate on the interval 0 to 2. We're going to multiply this all together. So we're going to have 16 pi times x divided by 1 plus 8x squared. And you can certainly factor out that numerator constant of 16 pi. But notice this, that we are going to be using the substitution method of integration. And if we let u equal 1 plus 8x squared, we are going to end up with this relationship, that du is equal to 16x dx. And that's already present here. So we don't want to pull out the 16 because 16 times x times dx, right there, 16x dx, that all gets replaced with du. So let's go ahead and do what we can. The pi, though, certainly can come out to the front. Our limits of integration are changing, so let's wait. 1 plus 8x squared is u. And now in this numerator, we have 16x dx, which becomes du. And in order to get our u limits, we're going to look up here. This is the equation that relates x and u. And so when we are dealing with an x value of 0, we plug it in up there, and we will get a u value of 1. When we have an x value of 2, we plug it right in there, and we are going to have 2 squared is 4, times 8 is 32, plus 1 is 33. So u will be equal to 33 when x is equal to 2. Well, this integration is pretty straightforward. That is the natural log of the absolute value of u. I'm not going to put the absolute value symbol, though, because we have positive limits, so we don't really need it. This will be pi multiplied by the quantity ln of the upper limit minus ln of the lower limit. And natural log of 1 is 0, so we get as our final answer pi multiplied by the natural log of 33.